Hi everyone, I am Dr. Kumudini, Assistant Professor, Department of Physics, Sadakatalappa College, Tirunelveli. Today let us see about the concept of viscosity, what is streamline and turbulent motion, what is critical velocity, and Poiseuille's formula for the rate of flow of liquids. Viscosity is a measure of fluid's resistance to deformation or flow. It describes the internal friction between layers of fluid as they move past one another. In simple terms, viscosity is the thickness of a liquid. High viscous fluids like honey or syrup resist motion, and low viscous liquids like water or air flow easily. The mechanism behind this is when a fluid flows, different layers move with different velocities. The slower layer exerts a retarding force on the faster layer and vice versa. The internal resistance to relative motion between fluid layers is called viscosity. The coefficient of viscosity, denoted by Greek letter eta, quantifies the viscous force in a fluid. It is defined as the tangential force per unit area required to maintain a unit velocity gradient between the layers, and it is given by the formula eta is equal to F by A into dV by dx, where F is the force applied, A is the area of the layer, x is the distance between the layers, and dV is the difference in velocity between the layers. The SI unit of coefficient of viscosity is Newton second per meter square, and in CGS units it is expressed in poise or Pascal second. Now let us understand what is streamline motion. Streamline flow refers to a type of fluid motion in which every particle of the fluid follows a smooth path and paths do not intersect. It is also called a laminar flow. The characteristics of a streamline flow are fluid flows in parallel layers, velocity at a point remains constant over time, and there is no mixing between layers. It occurs at low velocities and with highly viscous liquids. This type of flow is predictable and it is orderly. Now coming to turbulent flow, the turbulent flow is an irregular, chaotic flow regime characterized by small whirlpool-like regions known as eddies. Its characteristics are velocity and pressure vary unpredictably. It occurs at high velocities or in low viscosity fluids. Mixing of fluid layers happens in turbulent flow. It involves energy loss due to internal friction and eddies. Turbulent flow is disorderly and complex. We'll understand better with understanding of critical velocity. Critical velocity is the maximum velocity up to which the fluid motion remains streamlined. Beyond this speed, the flow becomes turbulent. So, up to the critical velocity, the motion is streamlined, and after that, it is turbulent. It is given by the formula Vc, that is the critical velocity, is equal to R eta by rho d, where Vc is the critical velocity, eta the coefficient of viscosity, rho the density of liquid, and d the radius of the tube. R is a dimensionless constant called as a Reynolds number, and it is usually around 1000 for circular pipes. So 2000 is a standard which fixes whether the motion is streamlined or turbulent. So less than 1000 it is streamlined, more than 2000 it is turbulent. Between 1000 and 2000 the fluid may be in streamline motion or can be turbulent. Now let us see the Poiseuille's formula, which describes the laminar flow of incompressible viscous fluid through a long cylindrical pipe. So Poiseuille gave a formula relating the quantity of liquid flowing per unit time. Here the flow rate is directly proportional to the pressure difference and the fourth power of the radius, and the flow rate is inversely proportional to the viscosity and the length of the tube. Q is given by pi p r power 4 by 8 eta L, where Q is the volume of liquid flowing per unit time. R is the radius of the pipe, P the pressure difference between the two ends, eta the coefficient of viscosity, and L the length of the pipe. Where the Poiseuille's formula finds applications. Let us see now. Blood flow in arteries and veins, flow of oil through pipelines, and designing syringe nozzles and 4 tubes. Hope you understood the concept of viscosity, critical velocity, streamline and turbulent motion, and the formula for finding out the volume of liquid flowing per second, that is the Poiseuille's formula. Thanks for watching this video.